Welcome to part 3 of 3 in the videos about converting repeating decimals into fractions. Alright, so in our first two parts, we dealt with the conversions of terminating decimals and also with the conversions of fractions that repeat immediately. Now we're going to look at the fractions for decimals that do not repeat immediately. So let's take a look at an example we actually mentioned in an earlier lesson, 0.16, and then only the 6 repeats. So in some conventions, that's 0.1 with a bar over the 6. Other conventions, it's a dot over the 6. But either way, it is exclusively the 6 that repeats. So we're going to do a mathematician's favorite trick, or one of their favorite tricks, and that's turning a complicated problem into a simpler problem that we've already solved. Specifically, we already know how to convert repeating decimals if the repeating starts immediately after the decimal. So in this case, we've got one digit before it starts to repeat. So let's call this number x. Well, then 10 times x, we shift that decimal place one spot. This is now a number that starts repeating immediately after the decimal. That is something we can deal with. So we have 1 plus our 0.6 repeating. I just pulled that whole number out because the method we had worked exclusively with zeros to the left of the decimal place. And now that fractional part is a 6 over 9, which reduces to a 2/3. If we combine our like terms on the right, or combine these into an improper fraction, 1 times 3 is 3 plus 2, we get a 5 over 3. So now our 10 times x, our 1.6 repeating, is the same as 5 over 3. Which means x itself is what we get when we divide both sides by 10. So that's 5 over 30x. Or 5 over 30. Sorry, we don't need that x there anymore. We take out our common factor of 5, and this has become a 1 over 6. So 1 over 6 is the fractional representation of 0.16 repeating. So our steps here. Count the digits after the decimal. Which do not repeat. So these are the ones that come before the repeating decimals. So multiply by 1 with that number of zeros, so that number we came up with in the first time. So if we have 3 digits after the decimal place before things start to repeat, we're going to multiply by 1,000. Then we convert just the decimal as before. We make an improper fraction. We do that by adding that whole number that we ignored in the first time. So we add the whole number we skipped in part 3. Now we have to undo what we did in step 2 by multiplying. Divide by the same number. We multiplied by in step 2. So this gets us back to our original number. And then the same final step in all of these is to simplify or reduce that fraction. So these are the steps to convert any rational number, so any terminating or repeating decimal, into a fraction.